What's up, guys? Dude, if I had $1 for every peanut butter and jelly sandwich I've had in the last 2 weeks, I'd be a millionaire. What's happening, guys? Welcome. Today is Wednesday, and we've got just not too much of a, it won't be too long today. I want to go over the video that I asked you guys to take a look at yesterday on standard deviation, on the empirical rules. So let's jump right into that. Let me get this set up here for you guys. Let's go here and let me fix these windows. All right, so let's take a look at a couple pictures here and we talk a little bit about standard deviation. So first of all, standard deviation is kind of a tool that is used in statistics that has its own rules. And it is based on a normal bell curve, like you see on the picture here. So when I say normal bell curve, it has to be proportional, meaning that if I kind of drew one here, meaning it has to look kind of like this. Proportional, meaning like the center would be right here, and everything is kind of evenly distributed to the left and to the right. So you can kind of see it's like that. An example of something that isn't proportional would be like this, where you can see that it is not half and half, like the middle of it is kind of way over here. So this would be called skewed, meaning that it's not, it doesn't look right. It's not equal on both sides. So standard deviation is a tool that we use when there is a distribution of data points is pretty symmetrical, like the picture that you see here. So here's how this kind of works. Standard deviation, what they say is that they look at the average or the center, and they pick points away from the center of the bell curve. Let me draw this again. So here's the center. That would be your average, your mean, and also in a perfect distribution, it would also be your median. So it's right in the center. And let me see if I can get this more centered. What standard deviation does is that they allocate points along the number line here, and then kind of down here, here, and here. And what they say is this: the first standard deviation away from the mean, which is the center. So the first point that you come to on either side of the center, if you combine these two here, that would equal 68% of all of your data points. So why is it 68% and not like 70% or 72%? That's just kind of like the rule of standard deviation. And as you can see on the screen, it's called the 68, 95, 99.7 rule. And it basically says this: the first standard deviation away from the mean on the plus side and on the minus side, 68% of your data points are going to be in that range. The second standard deviation away, if I looked at from the second all the way across, would encompass 95% of all of your data points. And you can kind of see it on the graph on the screen here. 95% of all the values will fall within 2 standard deviations of the mean, meaning 2 on the plus side and 2 on the minus side. So when you combine all of that together, that's 95% of your data points. And then the third standard deviation of the mean all the way out would count for 99.7% of all of your data points. So for example, if you had 100 different data points and it was on a perfect distribution like that, 95 of those 100 data points would fall within 2 standard deviations of the mean, meaning 2 kind of notches up and then 2 notches down. Between those 4 notches, 95% of your data points would fall. Okay, that's kind of what it means. And again, there's no reason why it's 68% and 95%. It's just one of those things that you kind of have to memorize. And just understand that a standard deviation is just a point away from the mean on the plus side or the minus side, and the gap in between those two account for 68% of all of my data points. So again, if you had 100 data points, 68 of them would be within one standard deviation of the mean. 95% would be in two standard deviations of the mean, meaning that they would all fall in between here. I could have all these different data points, and 95% of them would fall between here and here, two standard deviations away from the mean. Okay, and then almost all of them, 99.7%, would fall within three standard deviations. So why is not why it's important, because it's important, it's used all the time in statistics, but the way that they're going to ask you guys questions, it's really important to try to remember each step of the standard deviation on this graph, because they're going to ask us questions about, okay, what percentage of data points are between 1 and 3 standard deviations. So look at the chart that I put here on in front of you, where I've taken the standard deviations and I've broken it down by step. So here's my curve. I'll make it a little bit bigger. All right. Here's the median right here. So this is one standard deviation, and this is two standard deviations there and there. I realize my drawing isn't really to scale, but what are you going to do? We know that 68% of the data points fall between the first standard deviations on either side, right? So this is 68% from here all the way across to here, okay? Well, if that's the case, if I know that between here and here, 68% of the data points fall, because the median is exactly the halfway point, I know that between here and here is 34%, and between here and here is going to be 34%. Why? Because that's half of 68, right? So, and again, I could go to the second standard deviation and say, all right, well, here and here, I know that it's 95%, right? I'll draw this again. 95%, right? So if I've already accounted for 68% here and here, that's already been counted, what are these going to be? Well, 95 minus 68 is 27. So 27% of my data points are going to be combined in this area here and this area here. What's half of 27? 13.5. So 13.5% here, 13.5% here. And then again, if you go to the third standard deviation, you're left with 2.35% and 2.35% way down here. So 2.35% of all the data points are there, 2.35% of all the data points are there. All right? So it's important to remember the rules. So here's the things you have to memorize. And I know this is new, and it's just brand new information that, and again, it's one of those things we're just going to have to memorize these numbers. The first thing that you need to remember and memorize is this chart right here, okay? Between the one standard deviation away from the middle is 68% of the data points. Two standard deviations is 95. Three standard deviations is 99.7. When you break all of those in half, you can see what the percentages are here in this graph here. So I know that my first standard deviation away from the mean totals 68%. So when I divide that between the lower standard deviation and the upper, it's going to be 34% because that's 68 divided by 2. Same thing for the second standard deviation, same thing for the third standard deviation. So it's a lot to digest. I want you guys to kind of continue looking at these two charts that I'm showing you here if you have to rewind the video and just kind of remember how this works. But I also want to show you how the application of this. So what are some of the problems that we're going to be asked to do when it comes to standard deviation? So let's take a look. There's our banana dude. Let's go here. So let me see if I can make this a little bit bigger. Yes, I can. Okay, so here we have a pretty generic question about standard deviation. So it says 500 freshmen at Schaumburg High School took an algebra test and the scores were distributed normally, meaning it's a nice, even, perfect shaped bell curve like we see on the paper here. It says the mean is 75 and the standard deviation is 7. So right away, we can go ahead and label, hang on 1 second, let me make sure this is big enough for you guys. Okay, that's a little better. So let's go ahead and, well, Mr. Mac's famous lack of drawing skills here. So here is, let's see if I can draw this bell curve. Oh, not bad, not bad. So it says that the mean is 75. So we're going to do 1 standard deviation, 2, and 3. 1 standard deviation, 2, and 3. It says that the standard deviation is 7. So I can go ahead and label this. So this is my first standard deviation. So it's going to be 7 added to 75, which is 82. My first standard deviation below the mean is going to be 75 minus 7, because it's 7 away. So that would be 68. And again, I can fill in the second standard deviation. This is going to be 89, because again, it's 7 points away. And 7 points away here is going to be 61. The third standard deviation away is going to be 96. And then down here, it is going to be 54. Okay? So here's our mean, our average. This is 1 standard deviation. I'll put S there. 2 standard deviations, 3 standard deviations, minus 1 standard deviation, minus 2, minus 3, meaning that they're on the low side. Okay, so that's how you would label it. Now let's take a look at a question. What percentage of scores are between 61 and 82? So here's 61 right here. Here's 82 right here. So they're asking me the second standard deviation to the left. What's the range between here, or what percentage, I'm sorry, between here and between the first standard deviation on the right? Well, guys, the best way to answer this question is to go back and refer to our, our chart right here. So look, they're asking us the second standard deviation below here at 61. How many percentage points is it to the first standard deviation here, which is plus 1? Well, look, I can just go ahead and add 34 plus 34 plus 13.5, and that will tell me what the range of the percentages of scores fall between these 3 points, or these 3 standard deviations. So 68 plus 13.5 is 81.5. So 81.5% of all the test scores fall between 61 and 82. All right, let's go back and check out another question here. What percentages of scores are between 75 and 82? Okay, so now they're asking us from the mean here to this point here. What percentage is this? Let's just go back and refer to our chart. Well, between the mean and the first standard deviation, it's 34%. So 34% of the test scores fell between 75 and 82. Okay? This is kind of the style of question that they're going to ask you. Let's go back. What percentage of scores are between 61 and 89? All right. 61 is here. 89 is here. This is the second standard deviation on the low side. This is the second standard deviation on the high side. What's the percentage? What percentage falls between these two? Well, if you remember the rule, 68, 95, 99.7. 68% fall between the first standard deviation. 95% fall within the second standard deviation. So 68, 95. So the answer is going to be 95. If I'm not sure, let's go back to the chart and check it out. Where's my chart? Hello, chart. Chart. Boom. So from here, -2 all the way to +2, 13.5, 34, 34, and 13.5 is 95. All right. Let's see what other questions we can get here. Let's see. How many algebra students scored between 61 and 89? How many algebra students? Wow, okay, well, we just saw that 61 to 89, 61 is here at -2, and 89 is here to +2. I'm talking -2 standard deviations to +2 standard deviations. This gap here is 95% of all the people that took the quiz. Let's go back to that word problem. How many kids took the test? 500 of them. So what is 95% of 500? How do you multiply a percent times a number? You change the percent to a decimal. How do you change it to a decimal? 95%. Yeah, I'll just write it in the middle of this here. 95%. How do we do that? We just move it 2 decimal places to the left. So 95% is 0.95 as a decimal. And what is 0.95 times 500? 475. So how many algebra students scored between 61 and 89? 475 of them. Let's try another one. How about this one down here? Approximately how many algebra students scored higher than 89%? All right, so let's think about what they're asking us here. Where is 89%? Well, 89% is my second standard deviation right here. And they're asking us how many scored more than that. So we want to know all of these from here to here. How many scored an 89 or better? Well, what is this percent right here? It's the second standard deviation. Let's go back to our chart. Come on, chart. 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 Bruh. Really? Chart. Here's the second standard deviation right here. Okay? What percentage of students are above this second standard deviation? Well, there's 2.35% plus 0.15%. When you add those two together, that's 2.5%. How do I change that? Remember, they asked me how many students. They didn't ask me for the percent. They said how many. So it's 2.5%. What was the total again? It was 500 kids. So I need to multiply 2.5% times 500. So I've got to change this to a decimal. I mean, there's already a decimal there, but I need to get rid of this percent sign. So I do that by moving my decimal 2 places to the left, 1, 2, putting my decimal there. In the empty space goes a 0. So 0.025. There's another way to do this as well, guys, if you just want to use your calculator. Anytime you have a percent, to change it to a decimal, you just multiply this times 100. So if I multiply 2.5 times 100, it's going to give me 0.025. either way. And then I multiply that times 500. Let's get the old trusty calculator. 500 times 0.025, 12.5 students approximately. So between 12 and 13 kids scored better than an 89 on their test. So guys, it's the hard part of this stuff is remembering these numbers. So for now, use this chart here, and I'm going to put these two charts I'm going to put in Google Classroom just as a reference so you guys have them in order to answer questions. So all of these questions here are pretty simple. What percentage of students scored between one standard deviation and the other? Just go back to your chart and you can just look. What percentage is this and this? 34 plus 13.5 is 57.5. So if the question was how many students scored between 0 and 2 standard deviations, on the plus side, you would just add these two numbers together. That's pretty much it. Real simple there. The other type of question that you'll get is how many students. So you find your percent, and then you multiply that times the number of students, 500. Find the percent, change it to a decimal, then multiply that times 500. And again, how do you change something from a percent to a decimal? Take that percent, multiply it times 100. That will change it to a decimal. Then you can multiply that decimal times however many students there were. In this case, 500. If they gave you a different number, you would take the percent, multiply it times 100 to get your decimal, and then multiply that decimal times whatever the total number of whatever it is that you are looking to find. And guys, that's basically it for standard deviation. So just as a quick recap, standard deviation is a way that it's something in statistics that we use to break down data into kind of preset steps. And those steps away from the middle are called standard deviations. The way it works is that one standard deviation away from the center, that's 68% of our data. 2 standard deviations away from the center is 95% of our data. 3 standard deviations is 99.7. So like almost the whole thing is within that. Again, use these pictures, these charts here as a reference. The top chart just shows you the 98, 95, 99.7 rule. Then it's broken down into steps, or into each step. The percentages are broken down for you so that you can calculate how far is it from one step to another step. All right. I'm going to put a worksheet on Google Classroom. It's basically almost exactly like this worksheet here, where and almost the same types of questions. So I want you guys to give this a try tonight, and then I'm going to go over this stuff with you guys tomorrow. Hopefully you guys understand this. On Thursday, I am going to be in Google Classroom from 1 o'clock to 2 o'clock. So if not Google Classroom, Google Meet, from 1 o'clock to 2 o'clock. I will give you a link to get to the Google Meet room about an hour before. So about 12 o'clock on Thursday, or tomorrow on Thursday, I'll put a link in Google Classroom where you can come to Google Meet. Again, this is just if you need some extra help, you can pop in and I can try to help you. All right, guys, good luck with this stuff. If you're still a little bit confused, do the best that you can, and we will go over the worksheet tomorrow so that everybody understands it. All right, guys, have a great night.